Hi, my name is Modest, and today I'll be going over some problems that relating to physics and circular motion. So the first problem we'll do involves a satellite. So some of the prior information they give you is that the mass of the satellite is equal to 1,000 kilograms. They also give you that the satellite is at a distance of 4 times 10 to the seventh meters from the center of the Earth, which means that r is equal to 4 times 10 to the seventh meters. So the first question they ask you is, what is force net? So the way to find the net force in this situation is that because you know that the only net force acting on the satellite in this problem is the pull of the Earth's gravity to in the direction of the center of the Earth, you know you can use the force of the Earth formula. So you know that force Earth on the object, in this case the satellite, is equal to G, which as we see here is the gravitational constant, G times the mass of the Earth times the mass of the object, the satellite, over r squared. So simply here we know that G is a constant, which is 6.67 times 10 to the negative 11th. And then we know the mass of the Earth is 6 times 10 to the 24th. The mass of the object, which is 1,000. And then we have r, which is 4 by 10 to the 7th meters squared. And this comes out to be 250 newtons. The net force is equal to 250 newtons. The next part asks you to draw the force diagram. And as we had to conclude to solve the first part of the problem, the only force in this situation is the downward pull of Earth's gravity. Part C asks you to find the speed at which a satellite is going, and we know that the formula is the net force is equal to mv squared over r. So here simply we just plug in, we substitute in our numbers, so we have 250 newtons equals 1,000 v squared over 4 times 10 to the 7th, and we get that v is equal to 3,162.28 meters per second. And the final part of the question asks you to find the period of the satellite's motion, so how long it takes to go around the Earth one time. So here we know that v is equal to 2 pi r over t, so simply we substitute in, so we get that t is equal to 2 pi 4 times 10 to the 7th over 3162.28, which we found in the previous part C, and we get that t, the time, the period, is equal to 79,476.65 seconds. And that is how you solve a basic problem where they give you the mass of an object orbiting a planet, or in this case the Earth, and they give you the radius. Thank you.